In today's video, we'll be taking a look at a really cool little mini PC that could be ideal for people looking to build a small home NAS while keeping it as small and as neat as possible. And in particular, we'll be taking a look at the Beelink ME Mini, which is a tiny little Intel N150 mini PC that has space for up to 6 NVMe SSDs. But first, just so that I'm completely upfront, Beelink have sent me this over free of charge to take a look at, but they haven't told me anything to say, no money changed hands, and they won't be seeing this video before it goes live, so I'll be giving my own thoughts and opinions. But just so that I'm completely transparent, I'll enable the include paid promotions thing on this video. So, here we have the device, and it's a really neat little unit. In particular, it's the sort of thing you could happily have sitting out in your living room or office without it looking too out of place. So it's great for people who aren't like me and don't want to have a massive full-size server rack in their garage. You might just have your ISP's router sitting in your living room, or maybe something a bit nicer like a unified Dream Router 7, but you can connect the ME Mini into that and have it all sitting out in your living room, and the whole setup would still look pretty neat. In terms of pricing, at the time of filming, the bare version without any SSDs costs around £150, and the version I have here that includes a 2TB SSD costs £240. So this is a very affordable option, and is way cheaper than any other mini PC or NAS that I can find with a similar number of NVMe slots. And it's important to bear this price in mind when we look at it, because while there's definitely areas where they could have potentially done things differently to allow better performance, they would also have likely increased the price significantly. And this brings me on to the target market of this sort of device, and I kind of want to elaborate on that before I go further into the hardware, because I think it's important to evaluate who this is for before we go into detail. This isn't really designed for people looking for an ultra high performance NAS. Instead, it's for people who want some sort of network storage, maybe the ability to run a couple of apps like Nextcloud or Plex, while keeping everything as small, neat and as power efficient as possible. So this is what I'll be evaluating it against. This isn't designed to be an ultra high performance NAS for massive home labs or large business deployments. It's designed for very simple home users who want something with this form factor with low power consumption. So with that in mind, let's run through the hardware. As you can see, it's a very compact cube shape, and on the front we have a power button, a couple of LEDs, and a pair of 10GB USB ports, one being USB-A and the other one being USB-C. On the top we have an area for ventilation, with a slightly weird design where there's almost like clock markings embossed into the plastic around the outside and the slogan "Archive your moments" in various languages. Okay then. Then on the back we have a USB 2 port, a pair of 2.5GB Ethernet ports, an HDMI 2.0 port, and an AC inlet. And this connectivity all seems pretty reasonable. While 2.5GB Ethernet isn't going to give you the full performance of an NVMe SSD over the network, it's still a lot better than gigabit, and seems like a sensible option, since higher end home routers are starting to include 2.5GB Ethernet, and Wi-Fi 7 now makes it possible to get those sorts of speeds over Wi-Fi. So, if you say had the unified Dream Router 7 we mentioned previously, you could connect this at 2.5GB, maybe wire on a desktop PC at 2.5GB, and if you had a Wi-Fi 7 device, you could even get pretty close to 2.5GB over Wi-Fi. Of course, 5 or 10GB Ethernet would have been nice, but the cost difference likely wasn't deemed worth it. While this is an all SSD NAS, I'd view this more in terms of using SSDs for the reduced size, noise and power consumption rather than using them for maximum performance. Then of course the HDMI is nice to have, and with it being HDMI 2.0, it means that you could potentially connect this to a TV and use it as some sort of media center. And then the rear USB port could also be useful if you wanted to run something like Unraid on this, since it needs to boot from USB, since you could at least hide the USB stick behind the device. The next thing I found interesting with the hardware is the fact that they actually have an internal power supply, rather than an external power brick. And this is quite nice, especially if it's sitting out on show, since you don't need to hide the power bricks. The only downside of this is that if the power supply were to ever fail, you can't just swap it out as easily as you could with an external brick. So it's a bit of a double-edged sword, but as someone who hates wrangling tons of power bricks, I do quite like it. Finally, in terms of specs, we have an Intel N150 CPU, which is a slight refresh of the N100, 12GB of LPDDR5 RAM, which is soldered unfortunately, and 64GB of eMMC storage, which is a really nice addition since you could use that to boot your operating system and then leaves all the SSDs available for storage. So now before we fire this up, let's pop it open and take a look at the inside. On the bottom of the device we can see we have these 4 rubber plugs that cover the screws, so all we need to do is pop those out and get the screws out. So yep, we just get a little screwdriver in here, we can pop one of these plugs out, so it just pops out like that. It is just adhesive, so you probably want to be a bit careful that you don't completely ruin the adhesive taking them on and off lots of times, but yeah, they just pop out. They're more decorative than anything, you wouldn't really need them. A little screw under each of them, so we'll take all those out, get the screws out, and open it up. And now with those 4 screws removed, we can simply place it the right way up, and lift the top off. Like that. And now here we can see the internals. And it's actually a really nice, clever design. You can definitely tell that they've put a lot of thought into it. The whole unit is one big heatsink, and then all the SSDs are attached to it. We then have a fan on top that blows air through that to keep everything cool. So it'll be interesting to see how all this works from a cooling perspective and how quiet it is in practice, but it does look pretty clever. And then around the side of it, we can see we have all our NVMe slots, and in the first slot here, we can see the included 2TB SSD. This is an option you get when you order, so you can either get one that includes an SSD, I think they also do one that includes 2 SSDs, or you can just get it with no SSDs included and supply your own. And it's nice to see that they've actually included a proper, crucial P3 Plus SSD. They've not used some sort of off-brand, no-name SSD. You are getting a decent, real brand of SSD, which is really nice to see for something included in a device like this. It just means that you're getting something with sort of known performance figures and known quality, known write endurance, and specs that you can easily look up. Now, in terms of these slots, the first slot is PCIe 3.0 X2, and the remaining 5 slots are all PCIe 3.0 X1. And this is something that's important to bear in mind, but it isn't the end of the world in my opinion. When it comes to NVMe storage, it's always a bit awkward, since all of your SSDs require dedicated PCI Express lanes back to the CPU. With high-end server CPUs where you have upwards of hundreds of PCIe lanes, this isn't an issue. But when you start needing to use smaller, lower-powered CPUs, like the Intel N105 in this, which only has 9 PCI Express lanes, you start needing to make compromises. So here, they'll use one of these lanes for each of the Intel i226V NICs on the back here, and then that will leave 7 lanes available for the SSDs. So they've put 2 for the first SSD, and then use the remaining 5 lanes across the remaining 5 SSDs. It then just becomes a case of whether you want to have fewer SSDs with more lanes each, or more SSDs with fewer lanes each, and in this case, they've opted for the latter. So yes, this does mean that you aren't going to get the full performance out of your SSDs. However, a single PCIe Gen 3 lane can still handle almost 1 GB per second of throughput, which is almost double what you'd get for a SATA SSD. And realistically nowadays, NVMe SSDs are becoming almost equal in price to equivalent SATA SSDs, and it also means that they don't need to mess around with adding in some sort of SATA controller to the device. So that's the SSD base, and as I mentioned earlier, this also has 64GB of the onboard eMMC storage, and you could use that to boot your operating system. And now the final thing of interest inside the device is this Wi-Fi card. Now, you may think Wi-Fi in a NAS like this is a bit of a weird decision, but they're very much making this as if it's more of a mini PC with a bunch of PCIe NVMe bays, rather than being a dedicated NAS. And because most mini PCs do tend to have Wi-Fi, they've put Wi-Fi in this as well. And I suppose if you've got this as like a very sort of simple home setup and you maybe don't even have wired Ethernet, you could actually use this over Wi-Fi. However, one important thing to bear in mind with this Wi-Fi card is that it is only an Intel AX101, which is a pretty entry-level Wi-Fi 6 card, but it also only supports 1x1 MIMO, so it's not going to be particularly fast. Of course, you could upgrade this to higher speed Wi-Fi card and then get better speeds, but there is something that's really important to bear in mind, and it wasn't actually something I knew about until I started looking into this device. This Wi-Fi card uses an interface known as CNVIO, and this is an interesting sort of Wi-Fi card standard that Intel use on some of their devices. Compared to a normal Wi-Fi card like this Wi-Fi card here uses PCI Express to communicate, and all the components that required for Wi-Fi are in this single device. With a CNVIO card, a large amount of the hardware required for Wi-Fi is actually inside the CPU itself on the main board of the device, and then it communicates over a special bus called CNVIO to the Wi-Fi card that has much less hardware in it. Now, this slot is just a standard M.2 E-key slot, so you may think, well, you can just swap it out for any Wi-Fi card anyway. But it's not quite so simple. Not all devices that have a CNVIO card will have PCI Express lanes routed to their M.2 slot, and that seems to be the case here. On some devices, that's not a problem. They do have the PCIe lanes, you can just swap it out as you see fit. But with this device here, I can't see how they would have any PCIe lanes free to route to this slot, because you've got 7 PCIe lanes for the M.2 SSDs, and then another lane per NIC. When you've only got 9 lanes for the CPU, that's them all taken up, so I can't see where they'd be getting any additional PCIe lanes from. And just to test it out, I have taken this Wi-Fi card out and put in this PCI Express Wi-Fi card, and it just doesn't show up as a PCI Express device. So it seems this slot is purely for CNVIO and doesn't support PCI Express. That means that if you were to upgrade this Wi-Fi card, you would need to upgrade it for one that also uses CNVIO and not a more conventional PCI Express Wi-Fi card. And also bear in mind with the way CNVIO works, that some of the Wi-Fi hardware is integrated into the CPU on the motherboard and not all inside this Wi-Fi card. That means that there are potentially specific Wi-Fi cards that work with particular CPUs and others might not work, so you potentially couldn't just take this out and put a brand new Wi-Fi 7 card in, it might not be compatible. So you need to do a fair bit of research and make sure that the Wi-Fi card you buy is compatible with CNVIO and this particular machine's N150 CPU. This also means if you're thinking about potentially swapping this out for, say, a Google Coral TPU to use this as a CCTV NVR with Frigate, the Coral TPU that uses PCI Express also wouldn't work in this. The only exception to this is that this slot does still seem to support USB as well as CNVIO, so if you use a Wi-Fi card like this where it uses PCI Express for Wi-Fi but USB for Bluetooth, the Bluetooth works but just not the Wi-Fi. So if you had some sort of third-party M.2 card that fits in this slot that uses USB only, it would probably work, but I wouldn't expect to be able to swap this out just for any other PCI Express card. It is an upgradable Wi-Fi card, but it is a bit limited. So, that was a run through the internals. But before we close this up, let's just install a couple of additional SSDs just so that I can fully test this. Unfortunately, I don't have a nice set of matching SSDs, so I'll just have to use a pair of these 1TB SSDs along with the 2TB SSDs and at least give me something to test with. Obviously, if you were doing this properly, you'd ideally want to have matching SSDs and capacity that works well together in a kind of RAID configuration, but I'll just stick 3 SSDs in for now, just to test it out properly. And then on the topic of SSDs, I've just noticed that on their included SSD, that they've actually removed the sticker, or never had a sticker, on the side that contacts the heatsink, and then the only stickers are on the other side that isn't contacting the heatsink, so the bare chips are touching that heatsink through the thermal pad. So this might be something interesting to consider if you were wanting to get the absolute optimal cooling on your SSD. If you've got an SSD like this that's got stickers on the chips, you can maybe consider taking that off just to get even better thermal contact. Equally, it's probably not going to be a huge difference, and I'm not going to do that here personally just because this is just a test now. I want to be able to use these SSDs again elsewhere without having no stickers on them so I can see what they are. So just like to bear in mind that that's what they've done there. Kind of interesting, but yeah, you could take the stickers off your SSDs if you wanted, but I'm sure it'll work fine without that. Okay, so now let's get these installed. So as you can see, we've got the original SSD installed here, and interestingly, this is installed in slot 4. I remember seeing in the documentation that the included SSD was the one that was in the X2 slot, and turns out slot 4 is the slot that's X2, not slot 1, so just bear that in mind, that it's slot 4 that is PCIe Gen 3 X2, and also apparently supports SATA in this one slot if you wanted that. It's not slot 1, so just bear that in mind. So we've got the included SSD in slot 4, I'll install my 2 SSDs in 5 and 6 just so they're all on the same side so we can see them. As you can see, each SSD bay has a thermal pad included, so there's a little thermal pad behind here, and it has a bit of plastic on the front you can peel off. So if you want to install an SSD, you want to peel that off and then stick it so the SSD touches that thermal pad. There's also a couple of additional screw holes here, so you could fit smaller SSDs if you wanted to. But as standard, it's got screws up the top here for standard 2280 sized SSDs. Anything bigger than 2280, like some weird sort of X-server SSDs, would be too long for this. You're limited to 2280, but that's sort of the vast majority of SSDs. So all we need to do is peel off this thermal pad at the back here. Just try and carefully do that. There we go, that peels off. And then we'll take our SSD and install it. So we'll take the screw out of it there. Take our SSD. Also notice that the way the slot's orientated, it means that the chips on the top of your SSD will be touching the thermal pad. So the SSDs are almost being installed backwards so that they can make contact with that thermal pad. So that can go there, and that'll just push down into the slot like that. We can then take the screw and screw that back in. And that is our first SSD installed. Now, the only other thing to bear in mind there when I was talking about that thermal pad is obviously these 2 SSDs are single-sided, so the only chips are on the side that are touching the thermal pad. The third SSD I'm going to be installing is this one here that is actually double-sided. So this side here will touch the thermal pad, but the chips on the back, which is a couple of NAND chips and the DRAM cache on this SSD, wouldn't touch that heatsink. Just something to bear in mind. Now, personally, I can't see it really being a huge issue because these SSDs are not running anywhere near their sort of full sort of capacity, and these SSDs, you can install them in like a laptop with basically very little cooling. It's not like we're going for sort of peak SSD performance here, so you would probably be fine, but it is just something to bear in mind. Potentially, you will get better cooling on the SSD if you just go for a single-sided model, so that may be worth doing. Of course, I'm just testing here, so I've got no problems putting in this double-sided SSD just so I can test. But I thought that was also just worth mentioning, so yep, that goes in there. Like that, and then put the screw in. So there we go, that's our second SSD installed. And of course, needless to say, this will only fit SSDs that are like bare boards. You wouldn't be putting an SSD in here that's got like included a non-removable heatsink. That just would likely not fit in this case, especially the fact that they're being installed with the top of the SSD against this heatsink. So just bear that in mind. But yep, that's all 3 SSDs now installed. So now we can simply get the top case like that, put that back on over it, get those screws installed, and fire it up. So now to test this out, we have it connected to power, network at 2.5 gigabits, and we have it connected to this TV here using this HDMI port on the wall. So now let's power it up and watch it boot. So we'll hit the button there and wait for it to start up. And as you can see, it's booted up into Windows 11. Now, that does at first seem like a weird choice for a NAS, but the thing to bear in mind here is that Beelink aren't a NAS manufacturer. They're a mini PC manufacturer, so this is being treated more as a mini PC with a bunch of NVMe bays, rather than a purpose-built NAS. Of course, you could definitely use this with Windows and set up some sort of file shares or whatever, but I imagine most people will end up wiping this and installing something like TrueNAS or Unraid on it. So what I'll do now is I'll do a few tests in Windows just to do a few benchmarks, and then I'll go away and install TrueNAS on it. So now here we are loaded into Windows, and as you can see here we have the CPU, which is the Intel N150 quad core, our 12 gigs of DDR5 RAM, and then here we can see all our SSDs, and then down here we can see our Ethernet adapter, which over here we can see is linked at 2.5 gig. And then what I've done here is I've already formatted and mounted all the SSDs that I've installed. So we have the crucial drive that it came with, that's a 2TB drive in the M.2 slot, my 2 SSDs I installed in the M.1 slots, and then the eMMC storage is included here as well. So what I'll do now while we're in Windows is I'll do some disk performance tests, just so we can see the performance we're getting of these SSDs, and we can see sort of in proper actual figures how those bus speeds affect the performance. So for the first test here, we're going to use Crystal Disk Mark and run it on the Crucial SSD. So this is the SSD that's in that M.2 slot. So we'll run this and see what sort of performance we get. And there we go, as we can see, we're getting round about 1.7 gigabytes a second, both read and write, when we're looking at the sequential speed for this SSD. And that's basically exactly what I'd expect for an SSD in an M.2 PCIe Gen 3 slot. And there we go, I've now benchmarked the other 2 SSDs. So in the bottom left here, we have the Sabrent SSD I installed, and in the top right, we have the Kingston SSD. And as you can see, because these are only in the 1x slots, we're now getting read and write speeds round about 800 megabytes a second, which again is what I would expect for an X1 PCIe Gen 3 slot. So as you can see here, you're definitely not getting the full performance out of any of the SSDs in here, especially the ones in the X1 slots, but I'd say this is very much something important to bear in mind rather than a complete deal breaker. These speeds here are still significantly faster than you get with any sort of SATA SSD, and nowadays SATA SSDs and NVMe SSDs are basically equal in terms of price. In fact, I actually had to buy some SATA SSDs yesterday for the first time in quite a long time, and I was amazed by how limited the range was nowadays. It seems like a lot of manufacturers have just stopped making them or only really make 1 or 2 models, generally at the much lower end. So actually nowadays, it does make sense to start using NVMe SSDs in situations like this, where it's not really for the performance, but just because NVMe SSDs are now so much wider available, costs are the same as SATA, and in the future, I can almost imagine it going the other way, where NVMe SSDs become much cheaper and easier to get hold of, and SATA SSDs become the harder, more expensive, weirder, rarer ones to get. And the other thing to bear in mind here is that SSDs aren't going to get upset or whatever running at a slower speed. It's not like leaving a puppy in a cage that's going to get all upset because it can't get out and run. SSDs are completely fine running at these slower speeds. Yeah, you're not getting the full speed of them, but it's still a lot faster than SATA, and it'll work absolutely fine in this sort of application. And now the final results you see here are for the eMMC storage. So we're getting around about 200 to 300 megabytes sequential read and write. And that's actually pretty good for eMMC. I've seen eMMC that's like a fraction of that. Obviously, it's nowhere close to even a SATA SSD. But for just booting an operating system and doing things like operating system updates, it should still be reasonably quick. So yeah, for eMMC, these speeds are actually pretty decent. So now in terms of power consumption, here we are sitting roughly idle at the Windows desktop. It's occasionally doing updates and bits in the background, but it's mostly idle right now, and we're drawing round about 11 watts from the wall. Now, this isn't super low compared to other mini PCs, but the thing to bear in mind here is that we currently have 3 NVMe SSDs in this, and each of those will probably take a watt or 2. If you ran this with only a single SSD, you would draw much less power, but equally, if you're buying this, you're buying it to run multiple SSDs, so I thought I may as well do a sort of test with a reasonable number of SSDs in it. Of course, this is in Windows. We'll take a look later in TrueNAS and sort of see if it changes under Linux and things like that, but yeah, idle in Windows at the desktop, around about 11 watts. This is also outputting video, so if you weren't outputting video, it also might be a tiny little bit lower. And now here we are running a full Prime 95 stress test, and we're drawing round about 26 watts. So this is the sort of worst case power consumption you're going to see from this. Then in terms of noise, it's not too loud, but equally it's not completely silent. Right now, completely maxed out, it is audible, you can hear the fan, it's probably sort of thing equivalent to like a laptop really. When it's at idle, it's definitely a lot quieter. If you put your head right up next to it, or you're maybe, a metre or so away from it, you can just about hear the sound, so I maybe wouldn't put it like on a table directly next to where you're sitting, but if it's in a living room or really any sort of normal room, the noise isn't really going to be an issue. And even under full load like this, it's not like it sort of ramps up and screams and sounds like it's going to take off or anything. The noise is pretty much fine. So now, let's install TrueNAS on this. So I've installed putting a flash drive with TrueNAS on it, so all we need to do now is reboot. We'll pop into BIOS, take a quick look at the BIOS just in case there's anything interesting in there, and then we'll install TrueNAS on this machine. Cool, so here we are in the BIOS. It all looks pretty decent. It's actually quite a comprehensive BIOS. There's loads of functionality in here, so it's definitely not locked down at all, which is good. And it's nice to just see a normal conventional BIOS, no fancy graphical thing that just becomes a pain to use. So yeah, BIOS all seems pretty decent. So now we can come into here. We can tell I want to boot from the SSD or the USB flash drive there. And this should boot me into the TrueNAS installer. Yep, there we go. So hit that. I'll wait for that to boot and get on with the install. So now it's time to install TrueNAS. I'm not going to do the full installation on video just because that would be very boring. There's plenty of other videos out there on how to do it. But what I'm just going to show here is I'm going to install onto the eMMC. So you can see we've got my NVMe disks here, and then MMC block 0 is the 64 gig eMMC. So we're going to pick that and say we want to install to that. We want to erase that. Yep. So now I'll run through the installation process off camera and install TrueNAS to that eMMC storage. So now here we are booting up into TrueNAS, and it's all working. Now the installation didn't go quite as smoothly as I'd hoped. When I first went into the installation menu, picked the eMMC and told it to install, I got a weird error about something around the second eMMC partition wasn't available, eMMC partition 2 not available, something weird like that. I looked it up and it seems that this is a known issue with TrueNAS 2504, which is the current latest version. When you're installing to eMMC, for some reason it throws that error sometimes. And it doesn't seem to be unique to this machine. I saw a lot of people reporting the same error with various other mini PCs. Some people mention things around tweaking bits of the installer code and stuff to fix it. It does seem to be a bug more than anything. But all I ended up doing was installing TrueNAS 2404, so the previous version, and then after installing it, then updating it to 2504, and now it works absolutely fine. It very much seems to be a bug with the TrueNAS installer, rather than any sort of actual incompatibility with TrueNAS on this device. And now with TrueNAS installed to that eMMC, it's working perfectly. So we have the TrueNAS console all logged in. We can go over to storage here, we can see my sort of ZVol setup. There's 2 unused disks here. These are those weird eMMC partitions. It's these MMC block 0 boot partitions that for some reason show up. Again, just a little bit weirdness, doesn't really affect anything at all. But I've created a Z pool with my 3 SSDs. So as we go into here, we go into the pool, manage devices. This is a bit of a bodge because I've created a RAID Z1 with my 3 SSDs. It does mean that I've got a 2TB SSD and then 2 1TB SSDs. So I'm basically losing a terabyte of this 2TB SSD. This is not the way you would really want to set this up. It's just a test based on the SSDs I had to hand. So I've created a single RAID Z1 here. Realistically, if you're setting something like this up, you need to design your own storage layout based on your SSDs and your requirements. This is purely a test. Don't copy this particular setup. But yeah, with that setup there, I've then created some shares. I've exported them out over SMB. So I've created some datasets in that pool. I've created some shares, exported over SMB, and it all works fine. So now for the first test, I'm going to do a sort of general sort of transfer test over SMB to see what sort of speed we can get. So right now the ME Mini is connected to the network at 2.5 gig, as is this client PC. So what I've got is on the ME Mini, I've got one of my YouTube videos, a 13 gig file. I'm going to copy it from the ME Mini onto this machine. And before doing this test, I've already rebooted the NAS so that this isn't stored in any kind of RAM cache or anything like that. It is coming directly off of disk. So we'll copy that over there and see what sort of speed we get. As you can see there, we're sitting around about 280 megabytes a second, so we're absolutely completely maxing out the 2.5 gig Ethernet. Of course, this is nowhere near the full speed you'll be able to get out the SSDs in this. Obviously, if you're running an application locally on the ME Mini, you get the full speeds we saw before in Windows really for the SSDs, or in fact, you might even get slightly more because you'd be able to combine the speed of multiple SSDs depending on your sort of Z-pool layout. But right now, we're getting about 280 megabytes a second, maxing out 2.5 gig Ethernet over the network. So for a NAS with 2.5 gig Ethernet, being able to max out the NICs is really all you need. So for the second test, we'll now copy a file from my PC here onto the NAS. So I've just renamed the same file, so we'll just copy this back across, run that copy there. And as you can see, we're now sitting around about 250 megabytes a second, 240, 255. So that's working out to 2.2, 2.3 gigabits a second. So yep, absolutely fine again. The speeds, the exact sort of speeds I'd expect for SMB to this NAS. And then while I'm copying that file to the NAS in the background, we can see it's copying down there. We can sort of see the CPU usage here. We're sitting maybe around about 34, 36% usage. So doing a single file transfer like this at 2.5 gig, it's not maxing out the CPU at all. So you could probably have concurrent users or other things going on in the background without it really impacting the transfer speeds too much. Then as for power consumption, now we're booted up in TrueNAS here. We can see we're sort of sitting idle, sitting round about really 8.5 to 9 watts. It spikes occasionally if something happens in the background, but generally under 9 watts, which is actually a lot better than we're getting with Windows. So it's really good to see the power consumption under TrueNAS is still really good. Of course, that's sitting completely idle. If I try and copy a file to it at 2.5 gig, that'll obviously spike up a bit. So now we're copying a file at 2.5 gig, spiking up to maybe 15, 16 watts or so. But that is still really, really good. So yep, the power consumption is pretty low. The final thing I wanted to test out in TrueNAS is to run Jellyfin and use the built-in iGPU in the Intel N150 CPU to accelerate transcoding. So we've got Jellyfin installed here. I've just installed it as a TrueNAS application, so essentially it's running through Docker. Various configuration here, I'm not going to go into full detail, but I've configured it just to sort of mount a couple of directories that are already on TrueNAS underneath. And then if we go into the Jellyfin interface, we can pull this up here. And what I've done is I've uploaded one of my YouTube videos. And this is a very high bitrate 4K video, so it's a very high bitrate video. And then what I've done is I've configured my client here within Jellyfin to restrict my internet, my stream. So if I go into settings, playback, you can see here I've set my network quality to 10 megabit. So what that means is because this video is closer to about 70 or 80 megabit, this NAS is going to have to transcode that. So we can just start that playing. It'll take a little second to start transcoding, but give it a couple of seconds and then the video should just start playing back. There we go, so the video's now playing, that's all working absolutely fine. There's not much movement in the video, hence the fact it's obviously not really showing much movement. I'll try and find a section where I'm actually moving things. I do have a lot of videos where I don't really move stuff. There we go, there's a section with a bit more movement. So it is now working absolutely fine, so the playback is completely smooth. Jumping around the video is pretty quick, there's no real issues at all. And if we come into TrueNAS and we look at HTOP to see the sort of process usage, we can see on here that we are using FFmpeg, and if we go through FFmpeg in here, we can see here that this is set to use /dev DRI render D128. So this is using the iGPU to do the video transcoding, and it works absolutely fine. Now obviously I'm not a Jellyfin expert, it's not something I've used in a huge amount of detail, but this was a very quick setup. It seems to work absolutely fine with a very high bitrate 4K video. The transcoding is absolutely brilliant. Now it's maybe not going to be sort of perfect for if you're running absolutely tons of users off it, you might start maxing it out. But for a simple home NAS where you're maybe going to have 1 or 2 connected clients streaming video from it, Jellyfin on this works really, really well. And it's really good to see that iGPU just works completely out the box. The other thing I wanted to quickly try out on this was Unraid. Now, Unraid's not something I've really used much myself, but I thought it could be interesting to try out on this, especially just due to the way it handles all the disks. It could be a very good option for this sort of device where you could easily start off with just 2 disks and then expand just by adding individual disks as you go on. For example, you could start off with maybe 2 4TB disks, one as your main array disk, one as a parity disk, and then just add in more 4TB disks as time goes on. And then you could basically expand this up to 20 terabytes of usable capacity with 1 disk for parity. So that would be pretty decent. Now, I don't have an Unraid license, so I'm not able to start the array or do any actual disk testing, but we can easily enough come in here, go to main, we can see, yeah, we can create an array, we can add all our disks to that. It all seems to be working absolutely fine. So yeah, I can't really test this in any more detail, but Unraid does seem to start up and does seem to find all the disks. The power consumption is maybe a little bit higher than TrueNAS. We're currently drawing about sort of 10 watts from the wall, but that could probably be tuned. You could probably run something like PowerTop and use that to fix it. But yeah, Unraid seems to work as well. Now, of course, the only downside with Unraid is you do have to boot it from a USB flash drive. You can't install it to any kind of internal media like that eMMC, which would have been nice. But all you need to do is put your flash drive in the back. So I've just got a flash drive sitting in the back there, and it's neat enough having that. It would be really nice if Unraid did ever develop it in the future where you could install some sort of eMMC, but right now, you just need to boot off a USB stick. But yep, Unraid works fine. So now the final thing I wanted to test out was enabling secure boot to see if I could install an operating system and set up full disk encryption in such a way that it will automatically unlock on boot using the TPM. So I went into BIOS, went to secure boot, went to enable it, and I got this weird error saying secure boot can only be enabled when system is in user mode, repeat operation after enrolling platform key. And then there's various things online about how you just go to here and change that to standard, and then it says, do you want to install the factory defaults? But then that made no difference. It didn't seem to actually be working at all. So did a bit of digging online and found something. So I did a bit of digging and came across a forum post on the Beelink forum that linked to this website here, which seems to be some sort of like storage repository for various updates and firmware and things like that for Beelink devices. So the URL is dr, so like doctor, dr.b-link.cn. So we go to that, go to ME Mini, go to BIOS, and then in here, it's a little bit slow this website, then in here there's an option for Solve Secure Boot Issue. And if you come into here, there's two files. There's a Word doc, and that contains documentation instructions on how to do the fix. And then this zip file that contains some files you'll need. So what you need to do is download that zip file, and then copy the contents of that zip file into the root of a FAT32 formatted flash drive. Then what we need to do is reboot the machine and boot it from this flash drive, and hopefully we can install the appropriate keys to allow secure boot to work. So now with that flash drive plugged into the ME Mini, like we can see there, we need to go into the BIOS and tell it to boot from that flash drive. And that should, yep, there we go, it's taking me into an EFI shell. So there we go, and it seems to be flashing straight away. I think the instruction said I needed to run various commands, but it does just seem to be doing it. So it's a little bit scary, so I'll just let that run and see what happens. Okay, so now it says completed. That was slightly terrifying because it's not quite the same process that the document shows, because the document shows you it boots into an EFI shell and needing to manually run a flash command, and then the actual flashing process looks a little bit different in the document. But I suppose it's maybe the document's built for a different device or something. But yep, that apparently has flashed something, so I'll just try rebooting the device and see if I can now enable secure boot. And hopefully I've not completely bricked it. So run exit here, that should hopefully reboot me. Oh, we're back into BIOS, cool. So let's see if that now lets me enable secure boot. So nothing yet. Change that to standard. Yes. No changes yet. So what I'll do is I'll try completely rebooting the machine, come back into BIOS, and see if that's fixed it. Okay, that was slightly terrifying. I always hate when like a BIOS decides to maybe like retrain the memory I think it's doing, and it just sits for ages after updating the BIOS thinking you've bricked it. But back in the BIOS here, so let's see if now we can enable secure boot. Well, yep, so straight away I can see it's now changed system mode to user rather than setup. So now, if we press enabled, disable the CSM and setup, cool, that should be fine. So I can just disable the CSM. So CSM configuration down there, disable CSM support. So that's CSM now disabled. So I will then save that and reboot, and then go back into BIOS after doing that with CSM properly disabled, and hopefully now we can enable secure boot. So back into BIOS now, so secure boot enabled. Yay, there we go. So secure boot now seems to be enabled, so that's good. I'm going to save that, and hopefully we can then reboot, and I'll now try and install an operating system and see if I can set up any kind of automatic unlocking disk encryption using secure boot. And with that, I've now been able to install Ubuntu with full disk encryption. So we're booted up into Ubuntu here, and as you can see, we've got the Ubuntu data partition, that's 2TB LUX, LUX being the disk encryption. And as you can see, the padlock there shows it's booted up, it was encrypted, and it's now unlocked. So yep, that seemed to install absolutely fine up there. LUX encryption version 2 unlocked. So in theory, this should then be able to boot up automatically without requiring any encryption keys by using the encryption keys in the TPM and secure boot. So let's completely shut this machine down and then try and power it on completely from scratch, and hopefully it should boot up absolutely fine without requiring me to enter any decryption keys. Cool, so that's it powered down, so let's turn it back on again. So booting from a completely shut down state. There we go, so that's now the sort of Beelink post screen, so wait for that to finish. And there we go, that's now Ubuntu booting. And yep, that's worked. So now that's booted up. We've got login screen, we can log in here. Log me straight back in. And then like before, we can open up the disk management and straight away see in here that once again on that 2TB disk I'm using as boot disk, it's an unlocked encrypted drive. So this works really well. The setup was actually pretty easy. It's now built into the Ubuntu installer. The only thing I had to do is initially it gave me an error about the TPM being locked. I just had to go into the BIOS, clear the TPM and then do it. The installation process was completely fine. And it now means this can boot up can be set up with full disk encryption, but without needing a password to boot. It's the same idea as something like using BitLocker in Windows, and it means that if you wanted your NAS to be full disk encrypted in case it was ever, say, stolen, you could do that, and you don't need to then worry about any time there's a power cut, going to it and manually logging in. So, yep, a little bit weird there was that initial issue with secure boot. Not quite sure what's going on there, but at least Beelink do have a fix, and that fix was relatively easy to set up. Hopefully it is more of a bug with the initial firmware on this, and potentially future versions they sell will have updated BIOSes that don't have that issue. But if you do have that issue, at least you've now seen the process to fix it. But yep, if you want a NAS with full disk encryption that automatically decrypts, it does work. So there you have it. That was a look at the brand new Beelink ME Mini. And it's an absolutely fantastic little device for people wanting a very small, low cost and power efficient all SSD NAS. Of course, as you'll have seen throughout this video, this isn't some sort of extreme performance NAS. You do have fairly limited bandwidth on the SSDs, and you do only have 2.5 gig Ethernet. So it's not going to be the sort of thing you're going to want in a super high performance environment, but for a home user where you just maybe want something to store some files, store some movies, maybe do some sort of streaming with things like Jellyfin, and you're using SSDs more from a power consumption and general sort of size perspective rather than going for complete raw performance, it works really, really well. It's a really neat little form factor, it's way cheaper than basically any other all SSD NAS that I can find, and yeah, I really, really like this thing. So yeah, hope you found this video interesting or potentially useful if you're thinking about getting a small home NAS like this. But all I've left to say now is thank you very much for watching, and if you're interested in buying the Beelink ME Mini, I'll leave links in the video description and in the pinned comment.